Hello everyone. So today I'm going to show you how to implement a four-legged character and how to implement IK settings for that character. So as you can see here, the four legs of this character is firmly on the ground. Now even if he is walking on it is working on uneven ground, you can see the legs, two hands and the two foot are on the ground. So I'm doing this using IK, and that's the part I'm going to do today. IK settings for four-legged characters. And this episode is sponsored by this generous patron. Thank you very much for your support. Right, so as for our four-legged character, I'm going to use this stag. So yeah, using this skeletal mesh. So this same method should be able to use for a horse as well. Right, now I'll create a character. Wait, did I select character? So character, let's call it stag. Stag. Where is it? Okay, so now as this is a capsule which is not really suitable for a four-legged character, but still this character movement works only with this capsule, so therefore I'm gonna have to move with this capsule component. So let's, for the mesh, let's use this skdir stack. Okay, let's rotate it to align with the forward. And move down to match with the capsule. Alright, so now let's add a spring arm because I'm going to use this as a playable character. Let's attach it like this, and then let's add a camera under that. Alright, now let's drag and drop this stag into the level, and let's process it so I can play with that. Alright, let's see what happens. Still nothing. Okay, because we haven't implemented any, or we haven't even saved the map as well. So I have added the third person character, the default third person character, to the project. So therefore we can just copy movement and mouse inputs from this project. This is for gamepad, this is mouse input. Let's just copy this part into the event graph, and also right now let's see. Okay, now I can look around, but I can't look up and down. And also character moves with the camera, so to avoid that I think use control rotation U. We can disable this option. Oh no. Alright, here we have to disable this use phone control rotation. Now this should be enabled, otherwise it won't have the rotation input. Alright, right. Need to disable this. Okay, now it is working as expected. Alright, now let's see, move into movement inputs. So first I'm gonna set this to orient rotation to movement. It's already ticked. Okay, enabled. And then so what that does is it rotates the character towards the direction it is moving. So let's copy the movement input as well, like this. Okay, now the character can move. Now let's move into animations. This should be -90, not 80. That's why there was some problem in alignment. Right. Okay. Alright. And now do we have any blend spaces? No, we don't. Alright, so do this. Let's see. Work. This animation have root motion. Yeah. So therefore let's not use root motion for now and create let's first create an animation blueprint for these characters, for this character. PPA stag. Let's move it to the upper directory. Now here we need a blend space, so let's create a blend space now. And 1D blend space would be enough. Let's call this BSP stag movement. Okay, horizontal axis, let's try movement from 0 to 600. I don't know, we can see. Right, now here walk. animation should be here, and idle should be here, and run should be here. Alright, now let's drag and drop this here, a stag moment, and let's promote this to a variable speed. Now we need to update this variable somehow in order to play appropriate animation as the character moves. So let's first get in the event blueprint, initialize animation executed when the animation is initialized. Okay, here let's do this, drag it pawn owner, and let's promote this to a variable ch stag. Now let's just call it pawn, why not? And then here get the pawn is valid if there is a valid pawn reference, and then get velocity, get vector length, no, vector length, yeah, this gives the magnitude of the velocity, that means the speed, and set speed with this value. Alright, now let's go ahead and use this animation blueprint to drive this character mesh. Okay, we don't need to run, so let's set this to 300. No, that speed is not suitable. Then let's set it to 150. We have to change this as well. Yeah, that's better. Okay, that's enough to work on iCase. Well, to make things easier, instead of pawn reference, let's use let's turn this to a character. Right, now before setting this variable we have to cast to character. so that we can access the mesh component like this. Get mesh. Oh, we can't. Yes, we can get mesh. Okay, so the reason to have mesh is because we need to know where the foot location is. Alright, now let's try to resolve this problem. When we are in a place like this, you can see the front legs are on the ground, actually submerged on the ground, and the back legs are floating. So let's first prevent that problem. So how do we address it? Well, I think we have to do something like this. First we have to identify this point, and then this point directly below the hooves location, and then we would have to move down the character mesh and also adjust the leg positions. Okay, so first let's define a function to get the point, do a line cast, line trace, and get the point directly below one of the hooves. So trace no, yeah, trace. Now line trace by channel, and starting point is get phone. Let's name this socket trace, because I'm going to, no, sorry, not socket trace, leg trace, because we are going to trace legs, or maybe to make it more generic, bone trace. Okay, get mesh, and then get socket location. So let's promote this to a variable in socket name, right? And then oh, wait a minute, before doing this I need to study how does the bones work here. So let's see. Let's add a leg IK node here, and see how it behaves. So here's the leg. I'll add as the foot bone. Let's take a look at the bone structure. This is finger. Oh, this is foot, right? Let's copy this. No need to copy, we can just select. stag as the leg, foot. All right. Oh wait, this should be the, I'm not sure how to select this. Let's see. All right, if I set this to 1, it is like this. If I set this to -1, is that the way it's supposed to work? Okay, minus values have no effect here. If I set it to 0, it's like this. If I set it to 2, it's like this. Okay. Oh, maybe instead of doing this, we can use 2 bone IK. Here, let's select health foot. This should bend the other way, right? Yeah, that's how. Yeah, that's how the DLX work. So this target location should be here. Okay. Right, and now I'll promote this joint target location to a variable. Let's call it, this is left foot, LF, and joint target location, this should be world space, because otherwise it would be harder to do the calculations. Okay, now similarly let's add another toe bone IK, and this is for right foot. I'll promote this to a variable RF, okay, set it, and the effector also here should be in the back of the character. Wait, why can't I move it? this is target, this is effect. Right, that's better. Wait. Now promote. Okay. RF stands for right foot, and that also should be in the world space. Similarly, we have to add IK nodes for the front foot and that means hand, left hand and right hand as well. So to pawn IK, select our finger. Right. Okay, bending is all right. RH. Okay, another one more for the left hand. Okay, LH, world space. All right, now the IK setup for the forelegs are all right. The next part is we need to adjust the characters mesh location, because if the character is in a position like this, so first I will fix this. So first the character should move down a little bit, and then front legs should move up a little bit, and the back legs should move down a little bit. So that's how it should work. Okay, right, and the next challenge is now how to move the total mesh. So let's move What if I move this? What happens? Okay, let's add another transform modify bond here for the stag pelvis. So I don't want to rotate. Maybe I will need to rotate, but I will look into that later. I only need translation at the moment. So translation, it should be which one of these? It should be world space, and let's say replace existing. Okay, no, let's try add to existing. That's simple. And let's promote this to variable. Here we only want to change the set. Others I don't think we would have to. Pelvis, no, mesh correction. Set. Okay. So if I am to explain what I am trying to do again, let me draw a simple sketch. No, that's ugly. Let's use this one. When the character is like this, yeah, like this, no, let me open paint. Yeah, when the character is like this, what I'm going to do is first I'm going to move the whole character down a little bit, and then these are up and these are moved down, so the character's foot and the legs, foot and the hands will be firmly on the ground. Okay, now using this bond trace, uh, let's say I want to get do a trace for the left foot, so I'm only going to get XY location from the bone, and then I'm going to derive the Z location for the starting point using the character location, because this will be modified anyway because of the IK locations. And if I add that variable change in part into the calculation, then the calculation could be a problem, because as I modify the location of the bone inside the animation graph. So therefore, let me break this, and then make wake make vector, right? For x and y, use them directly without any issue. Now let's rename this character, because this is not a pawn anymore. Get actor location, split, and get dz from that. So this is the starting point, and the ending point would be at let's say, what's the capsule height here? 88. Okay, half height is 88, then let's say minus 200. Right, and I leave the debug type like this. Then we need a return node. So this is to denote that if it is a hit or not, and then break the hit results and give the location. Okay, now here I'm going to do the traces that I need for IK calculations. So first, pawn trace. First thing I need is the root. That's the middle, right? Not really middle. Anyway, let's use root for now. Okay, and keep it for now. Another pawn trace. This is for left foot. And another one, that's for our foot. And two more for hands. Finger, and our finger. Okay, let's see. Right, we do get the location correctly. Okay, and one more thing in here. I don't think I have to change X or Y. I would only need to change the Z. Right, so let's promote this alpha to a variable ik alpha, and then use it for so the default value of this should be 0, and then let's see. Okay, now we get the traces correctly. Then let's update the ik value based on the speed of the character. Like this, set ik and get ik love like this. So 1, select B based on the speed. If the speed is larger than 0, if it is true, then this should be 0, otherwise it should be 1. Maybe we can use some value like 5. Oh, we need to set this. Right. Okay, now let's see how to adjust. So for the rock, using this root socket, we can no, not yet. Let's work on the legs first. So get this one, let's set it like this, set LH set, sorry, this is not LH, this is a left foot, and this is set RF, right foot. Set LH, left hand, RH, right hand. Okay, let's see what happens. Not exactly what I expected. Sorry, this is effect allocation and this is target location. Okay, so I should use effect. That's what I should change. Yeah. Yes, that's what I should change. If I break this, now I can move it. Wait. Oh wait. Let me disable them all and correct it. Joint target location should be the default component space and this one should be world space. Okay, now let's fix one by one. This is effect and this is target. Why it's not moving? Right, this is effect, of course, and this is target. Correct. Now let's connect this and this. Alright, now let's do the same for the right, sorry, left leg, left foot. Let me break alpha. This is effect, this is target. Okay. And let's play the game and see if there are any difference. Right foot is correct because it's trying to move to the ground, but left foot is not. Let's see. Alright, this should be world space. Right, now both back foots are okay. Alright, now let's do the same for the hands. This is effector, and this is target. Okay, right, that's the effector. Now it should show some better results. Right, now you can see the legs are trying to move to the correct position. Okay, and also you can see in here for each leg there is a slight offset like this, so we need to account for that. So to for that, let's add another parameter here like this. Should we do that here? Yeah, like this. Let's call it set offset, and here, so for the set offset, let's say 10, not minus, plus 10 for all of these. 8. Let's change the default value so that we can easily see it. Yeah, now it's better. 10 is better. Okay, now we need to adjust the main mesh offset. So for that, how should we do it? Let's try something like this. Here let's set mesh offset. How to calculate it? Get LF, get RF, split, let's collapse this part, otherwise this would be messy. Get the main and minimum of these two. Well, actually from all RH, split, and LH, split. Right, and then get actor location, so get the character, get actor location, and then split this. Get this, subtract this one. No, get half height of the capsule. Subtract this so that we can get the bottom point of the capsule of the character, and then subtract this value from that so that we can get the difference between the character capsule's lowest point and the lowest point that we get from the traces. Okay, and then divide this by 2 because we don't need to move the total amount, only half of it down as the mesh offset. Okay, now let's see. I think character is moving up. Let's leave the visibility of the capsule so that we can clearly see what's happening. Yeah, okay, it's moving up, so that means we have to change this. Or make it minus. So it works for places, for some places, but not always. When the angle is slightly no, that's not good. Alright, here we have a problem because we have this offset, so we can't use that offset here. So therefore we have to add -5 to correct that. Shall we see what happens if I rotate the body of the animal? So to rotate, let's see, rotation should be add to existing. Let's see what happens. Roll. Okay, roll is the one we should change. Let's try promoting this to variable. Rotation offset. Okay. So let's set the rotation offset like this. Get the minimum. Now let's get the average. Of average Z of left foot and right foot divided by 2, and get the same from left hand and right hand. Okay, and then get the difference. Then let's clamp this between -30 45 and +45. Set. I think we may have to divide this with some value to get more sensible rotation. Let's try. Now let's print this and see, so we can find out a proper value. Yeah, that's much. Oh wait, let's remove this one. I can't read the value. This is funny. Okay, the value should be much larger here. Let's try 5. Not good. Okay, let's disable this mesh offset for now and go with only the rotation offset. Maybe that would be better. Not really. It looks ridiculous. What if we do something like this? Let's move the character back to align front legs with the capsule. No. It should align with the pelvis. Okay, let's try that. And see. Yeah, now it looks better. And let's keep this rotation offset always, so it would be better. Yeah. And we should rotate the character to account for this as well. So it looks fine for an angle like this, but it doesn't look cool when I am sitting like this. So we need to fix that for that situation, but I will do that part in another episode. Okay, so here is the final preview. Deer can walk like this, and foot location adjust properly. Let me place some objects here so that we can clearly see the effect. So with this I'm gonna stop this episode, and the project files will be available through the Patreon page. So I think I will do another episode to make this system, to improve the system actually. So if you would like to support my work, you can get the membership of the Patreon club. The link would be in the description below, and thanks for watching. See you in the next episode. Goodbye.